Good morning, my YouTube viewers. Crystal here. What I wanted to do this morning is I wanted to make a video on the Titanic because I have done some more work on the Titanic data set. One thing that I will say is that no matter what I've done, I've never really been able to get my accuracy above a 78%. I've heard of some people that were able to get the accuracy at 84, 85%, but they said that past that, they couldn't do it. That what people do is they go into the news and find out the survivors and write their program for the survivors to pass. But that's not really what you're supposed to be doing. You're supposed to be writing the program on the train test set, not the test set. I wanted to give you a video on this because I've done some more work. You can see that I just submitted my submission and we got 77.51%. That's not my highest score. My highest score was around 78% when I did an ensemble one time, but I've never got above 78%. What I did this time was I did stacking, and as you can see, I scored a little bit higher with the stacking than I did the ADA Boost classifier. I may try bagging sometime, see if my score improves with bagging, because I did bagging the other day and my score on another data set improved with bagging. So we'll look at the stacking, and you'll see that the submission was successful and I had a public score of 77.511. What I'll do is I'll set this up to make it public. So you can call it up and look at it if you want to. It's under the stacking data set. So with this Titanic, the first thing we'll do is we'll read the problem statement. The sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there wasn't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. So that's your problem statement of the Titanic. So the first thing that we do is we load up the libraries that we think we're going to be using. The minimum that you're going to need is Pandas and NumPy, but you're also going to need Matplotlib. And I don't recall whether I use Seaborn or not, but it's in there. Then we're going to load the files. And in this instance, I used the notebook in Kaggle because Kaggle wants you to keep your work in the notebooks in Kaggle. So we had to use the notebook in Kaggle. And then we read the files. We read the train file and the test file. We checked for any null characters. You can see age, we had null characters. Cabin, we had null characters. Embarked, we had null characters. And fare, we had null characters. So I dropped a few columns. I created a variable called ID train and ID test, and I dropped passenger ID on train and test, but kept the data in those variables. So we dropped passenger ID, cabin, and ticket from the train and the test both. So you don't need those columns because the cabin had a lot of missing data and the ticket had a lot of missing data. So we just dropped those columns. We use KNN, that's your nearest neighbor imputer, and we looked at the 50 nearest neighbors to impute age. And then we made age an integer. So K nearest neighbor, what that would do is it would look for the 50 nearest files and then give you an age related to the 50 nearest files. We also did that with the fair. And the next thing we did was we replaced our missing values with mode. Those were your objects because definitely iterative imputer. I think that works only with numbers, and I'm not sure about K nearest neighbor. That might work only with numbers again. But with the objects, we replaced the objects with mode, which is the most frequently used variable. And then we checked for any missing values, and we did not have any missing values. Oh, I know what happened with this mode. What happened with the mode is if you'd have to ordinal encode the mode, and then if you ordinal encoded the mode, the ordinal encoder wouldn't work because it had missing values in it. So you would have to replace those missing values before you could ordinal encode it. And that's why we had to use the mode command. So that's why, because if I had my choice, I would use the iterative imputer throughout the whole program. But because some of the missing values were objects, I wasn't able to do that. And so rather than using the iterative imputer, which is what I would have liked to have done, I used the KNN imputer, which is your nearest neighbors. So now what we do is we do a graphical representation of the data set. We do another graphical representation of the data set using group by. And now we're going to pre-process the data. So we put the data in the ordinal encoder. So we've ordinal encoded sex and embarked. So now what we do is we take the title from the name. And then we had to split the title from the name. And we used like a locally made formula. So you have to train title equals train name map lambda name colon name split comma 1 split period 0 strip. So if you go back here and you look at the name, we'll see if we can find the name. No, we can't find the name because I took the train test off just to save it. But if you went back and looked at the name, you would see that it would be separated by a comma and a period. But you can't see it here because I took train and test off just to save space. So now we've got the title, and it says here we've got 16 titles, but actually we've got 18 titles because number Donna was in there, but somehow or other it didn't get in there when we separated the title out of the name. And so now what we've had to do is we've mapped the titles, we've mapped it. And so everything has a number now. Then we do the same thing with passenger class. It's got 1, 2, 3. We group by the passenger class 1, 2, 3. We check our sex, and we group by the sex. we check our age, we group by the age, and now what we do is we make a chart of the ages, and now what we do is we bin the ages, we make bins for the ages as well. So rather than all of the ages going in there, it just says child, young adult, middle-aged pensioner. We create a column called age range out of age in the bins. And then so you've got we create a group by pivot table with the age range. And now what we do is we take the age range and we assign it to a number, because everything has to be numeric. And then when we assign every category in the age to a number, we do it again. So rather than saying child, young adult, middle-aged pensioner, it just says 1, 2, 3, 4. Now what we do is we take the family and we add sib, spouse, and parch together to make family. And then we use a group by function to check out the family to see how many we have in each family. And we graphically represented that with a bar plot. We do the same thing with fair. And we created some bins with the fair to say, give each fair a category and call that fair range. And then we did a group by on fair range so you can see all the categories. But then what we have to do is we have to assign that a number. So we've mapped the fair ranges with the new numbers. And now you can see that your fair range is a number now. We did a group by on embarked at 0, 1, 2. And you can see how many people embarked where. Now what we've done is we've done a heat map. So you can see a heat map and you can see how all of the independent variables influence the dependent variable, which is survived. Now we set up our X and Y values. So Y equals train survived. And then we set up some features. Features equals passenger class, sex, family, embarked, title, age range, fare range. X equals train features. X test equals test features. Now we split our training up for testing and validation. X train, X val, Y train, Y val equals train test split. X, Y, test size equals 10%. Random state equals 1. Stratify equals yes. Shuffle equals true. And then we check the values. We check the shape. Now we set all of our answers up in a scaler. So all of the answers will be scaled probably between 0 and 1. So we fit the train, X train, into the scaler, and we transform X train, X val, and X test. So we count the values in the validation set, and then we graphically represent the validation set. And now we have our formula for class weights. And now what we do is we do our stacking. And so we didn't actually use class weights in this instance. I could go back and try it again and see if I can get my value a little bit higher. But so we said class weights is balanced, but I could have put class weights in there, and I might go back and try it again and see if my accuracy is better when I use class weights. But you can see here, we've set up our estimators, and so we've got random forest, linear SVC, gradient Bayesian classifier, SGD classifier, Gaussian process classifier. Those are just some classifiers that I picked out, and I probably could have picked out more if I had wanted to. But what I noticed is even whenever I added classifiers, it did not really seem to improve my accuracy. And your model is your stacking classifier. So your estimator is your estimators, which we've already defined. Your final estimator is logistic regression. And I set it up for C equals 1, class weight equals balanced, random state equals 1, fit X train Y train, and you print model score X train Y train. So that's given us an accuracy of 85%, which is not too bad. And we predicted on our validation set, gave us an accuracy of 77.78%. Put it on a calendar, a counter, and we visually represented it. And now what we've done is we've made a data frame to compare the actual validation values with the predicted values, so you can see for yourself. Now what we've done is we've predicted on the test set, and after we've predicted on the test set, we have created a data frame. And when we created this data frame, we called it submission, or called it my submission really. And then what we did is we saved it. And when we saved it, we created a submission file, and we pressed submit. We submitted that to Kaggle, and we submitted it to Kaggle. We got a 77.511%. Now what I might do is I might go back and check the class weights and see if that improves the score any. But it's just been my experience that I can't really get it above 78. I've got it at 78 twice, but this is almost the highest that I can get it, although I know that other people have gotten it higher. But I just wanted to show this to you to illustrate how you do stacking if you want to try stacking out. So thank you so much for watching this video. If you like my work and you want to support me, you can like, subscribe, and share. I've got my email address for my PayPal account down below. And if you want to make a donation, because I don't have enough subscribers, and as a result of that, I have to ask for donations because I can't get monetized. And let me know what you think about this video, if you've got any ideas, if there are any other tricks that you want me to be aware of. I certainly would be interested in hearing about it. So thank you so much for watching this video, and I look forward to making new videos for you.